Welcome, ladies and gentlemen, to this video lecture. So we want to be able to compute integrals of this form. And the first form that we will look at is when we have odd powers of sine and sine or cosine. Sine or cosine. Okay. So let's take a look at what will happen. So let n and m be natural numbers. And what we will keep in mind is that we will use the following trigonometric identity. So sine squared x plus cos squared x is equal to 1. So if we have an odd power of a cosine, so for example, if we have sine to the n x cosine to the 2m plus 1 x. So here we see we have an odd power of a cosine. So let us take out one of these cosines and write it as follows. So we've got sine to the n x, and let's take out one of these cosines. So we're left with 2mx, so let's write it as cosine squared x to the n. And now, using this identity, let us convert these cosine squareds to sines. So what do we get? We get sine to the n x, and this term, or this factor then becomes 1 minus sine squared x to the power m cosine x. Okay, and now we see here and here we are in business. If we keep in mind that the derivative of sine is equal to cosine, what do we see here? We've got sine to the n x 1 minus sine squared x to the m multiplied with the derivative of sine x. And remember, this is the form that we wanted to get. Some function applied to some other function multiplied with the derivative of this other function. So we see here, what do we have here? We've got some polynomial applied to sine of x multiplied with the derivative of sine of x. And we saw that if we have something in this form, this then becomes easy to integrate. And what is this p? This p is a polynomial. For a polynomial p. Okay, so that is if we have an odd power of a cosine. If we've got an odd power of a sine, we do exactly the same, only with the sine. So if we have sine 2n plus 1 times cosine to the m, what do? Let's take out one of these sines. So put it at the end, sine x, and let's write this remaining factor, sine that then become sine n. No, actually I want it this way, sine squared to the n cosine n. And now again we use our identity, sine squared plus cosine squared is equal to 1. So this becomes 1 minus cosine squared x to the power n cosine m sine x. And again here you see the sine x, let's write it like so. Put a minus in the front, put a minus in front there. This is now the derivative of the cosine. So derivative of cosine is sine. So for some polynomial q, this is now equal to cosine x. So this polynomial q applied to cosine x multiplied with the derivative of cosine x for some polynomial q. Okay, and we've already seen that if we can get our integrand in this form, then our integral is easy to compute. Okay, in the next video we will look at a example.